Hi guys, this is our new lesson. We're starting our new unit on exponents. So today we're going to go over the different laws of exponents. So your different laws, some of them you should know already. For example, the first one, the product law. If, for example, I had x squared times x to the fifth, we should know that you get x to the seventh, because the rule is that we add the exponents when multiplying. Second, we have the quotient rule. If, for example, we had x to the sixth divided by x squared, we should know that you get x to the fourth, because the rule is that we subtract the exponents. Number 3 is your power rule. This is the first power rule we're going to deal with. Power to a power. If, for example, I had x to the fifth squared, one base with two exponents, you get x to the 10th, because the rule is that you multiply the exponents. Four and five are similar. They're another type of power rule. When you have two things being multiplied in number 4 with one exponent on the outside, you can distribute the exponent inside so they both get it. Similar with number 5, if they are dividing, you can distribute the exponent into them that way as well. So they both get that exponent. So if, for example, I had 2 over x to the third, both the 2 and the x would get the third. And I realize that example should actually be for the next one with the division. But we're the right one for 4. Let's say we had 2x being multiplied to the third. They would both get that third and stay multiplied. So that's those two different power rules. We distribute the exponent into the parenthesis to everything that's in there. Number 6, we have our negative exponent rule. What a negative exponent does is it takes you and switches you to the opposite side of a fraction. For example, this first x here is technically over 1. So what happens is it switches to the other side, the x, so now it's in the denominator, and its exponent turns positive. Now that x on top, it was really a 1x. That 1 stayed on top. For example, if I had 2x to the negative fifth, this whole thing is technically over 1. So switching to the other side would be the x, and that 5 turns positive, but the 2 would stay on top because that 2 and x are two separate things. Likewise, if the x is in the denominator with the negative, that one then switches to the top, the numerator, and the exponent turns positive. For example, if I had that 1 over 2x to the negative fifth, that x would switch to the top. The negative 5 turns positive, but the 2 stays on the bottom because the 2 and the x were being multiplied. Only the thing with the negative exponent switches to the other side of the fraction. And the last rule that we need to know is your zero exponent, anything to the zero power, is 1. For example, if I had 5x to the zero power, that whole thing would equal 1. So now we're going to try some examples. When we go through these examples, first thing I'm always going to look for is going to be one of my power rules because they deal with parentheses, and parentheses always go first. The last rule that we are going to always deal with is the negative exponent rule. So you'll see what I mean when we do the next few problems. So notice the directions say simplify and express with positive exponents only. You only want positive exponents in the end. So number 1 here, no parentheses we have to deal with. These two things are being multiplied. And when we multiply, we're just going to multiply together the like terms. So negative 4 times 5 is negative 20. Regular numbers get multiplied just like you normally would. Variables now, if I am multiplying, that is finding a product. So we are doing our product rule, which means we are going to add the exponents. So x to the third times x to the fourth, we should get x to the seventh because we want to add the exponents. So those were the x's. Next, I have the y's. These y's are also being multiplied together. So again, I'm going to add the exponents. So y squared times y to the first. If you don't see an exponent there, it has an exponent of 1. And 2 plus 1 is 3. So we did the multiplying. That was the simplifying piece. It then says express with positive exponents only. My exponents, the 7 and 3, are both positive. So that is your final answer. Number 2, I said parentheses should go first. So right here, we have our power rule. 1 base x, 2 different exponents, 2 and n. So power to a power, we multiply. So that gives me x to the 2n power. And then times x to the 3n. I'm going to bring that x to the 3n down. When you're simplifying, there should only be one x left over, one y, one z, whatever variables you're dealing with. I should not see multiple of them when you are done simplifying. So right now I still have more than one x sitting here, so I need to keep going. This is now my product rule. They are being multiplied, which means we are going to add their exponents. So we get x to the 5n. 2n plus 3n is 5n. And now since I have only one x sitting here, that is my final answer. Number 3, these are being multiplied again. So this is your product rule, which again means add the exponents. So we get g to the 3 plus negative 7 power, which is negative 4. I'm done simplifying. I only have one g sitting here. But be careful, because we did say we want positive exponents only. Right now I have a negative. So remember, this g is technically over 1. So the negative rule switches it to the other side. So now that g is in the denominator. It was in the numerator on top. Now it's in the denominator, and the exponent turns positive. There was technically a 1 in front of that g, so this is 1 over g to the 4th. Question 4. Here's a negative exponent. Luckily, there is no simplifying that has to happen. I already only have one x sitting here. I don't have multiple x's I have to deal with. So the only rule I have to do is take care of that negative 3 as the exponent, because the directions wanted us to have positive exponents only. So we're going to take it. It goes to the other side of the fraction. So the x was on the bottom in the denominator. It is now on the top in the numerator. And the exponent goes from negative 3 to positive 3. Technically, that x down there had a 1 in front of it, so there is still a 1 in that denominator. Anything over 1 is itself, so you can just write it as x cubed if you want. You do not have to put it over 1, but if you leave the 1 there, it's not wrong. Question 5. Again, like the last one, luckily there is no simplifying that has to happen because there's already only one m sitting here. I don't have multiple m's in the problem, but we have to take care of that negative exponent. So right now this is over 1. So switching to the bottom, the m is going to go to the bottom and the exponent turns positive. But that 2 is not part of the exponent, so the 2 stays on top. Only the variable with the negative exponent will go to the other side. Question 6. I do see parentheses, however, there are no exponents on the outsides of these parentheses, so I actually do not have to do any power rules. If there were numbers, exponents on the outside of the parentheses, then we would have to do a power rule. But since there is not, we can just drop the parentheses. There's no need for a power rule. However, we are going to use our product rule. And the product rule means that we are going to add the exponents. Now, it's adding the exponents. We are still multiplying, so the 5 and the negative 3 do still get multiplied to make a negative 15. It's the exponents that we are going to add. So for the x, 5 plus 2 becomes x to the 7th. So I consolidated down to 1x. I do not have multiples anymore, so I'm done simplifying. My exponent is positive. The negative 15 is not an exponent, so it just stays a negative 15. We're looking at the exponents. They have to be positive, so the 7 is, so we are done. Question 7. Parentheses. We do have our power rule here. Power to a power. We multiply. So 2 times negative 3 I get x to the negative 6 power. Done simplifying, but now we need our answer to have positive exponents. So the x is in the bottom, it's going to go to the top. So the exponent can turn positive. The 3 was on top. It is going to stay on top because the 3 did not have a negative exponent. So the 3 stays where it is. The x had a 1 in front of it, so the 1 is going to stay. If it's just a 1 down there, we don't have to show it. If you want to, you still can, but you don't have to. So this answer could either be 3x to the 6th over 1 or just 3x to the 6th. Number 8. I have a few x's I have to deal with here. First thing I would do would be the top if I were you. Since there's more than one x on top of the fraction, I would take care of that first. They are being multiplied, so this is your product rule, which again means add. So on top, the x, negative 3 plus 4 is x to the first. X to the 8th is still down in the denominator. These x's, I'm not done simplifying because I still have more than one x in my problem. These x's are being divided, which is your quotient rule dividing. So the quotient rule means that we are going to subtract the exponents. So 1 minus 8 is negative 7. We are done simplifying. This x is over 1. I need a positive exponent. So the x is going to go to the denominator, and its exponent turns positive. And that x on top had a 1 in front of it, so that 1 is still on top. So your answer is 1 over x to the 7th. Let me know if you have any questions. Laws of exponents can get very tricky and confusing, so please let me know if you're stuck or confused on anything. I want to help. Leave me a message on Google Classroom or send me an email, and I'll be more than happy to help you.